So my presentation is about forecasting. One second. I can't see my screen. Oh, let me unshare and reshare. Okay, so my presentation is about forecasting elite athlete performance using automated machine learning in XGBoost models. This is specifically in the Premier League, the English Premier League. So I'm using Fantasy Premier League, which is it's a pretty popular game in the UK, similar to like fantasy football in America, where you select a team of players and they are awarded points based off their real world performances. So like if they score a goal, get an assist, keep a clean sheet, anything like that. So it works as a good proxy to measure overall player performances. It also presents an optimization problem because you have a constrained budget, certain positional and player rules. So I'm going to try to optimize that as well. My main research questions are how well can the machine learning models forecast individual player performances? And how well do the automated models and how well do the models compare against expert FPL managers, and how well do they compare against each other in a simulation of a season? And how reliable is FPL data as a proxy for like athlete performance forecasting? So the first thing I have to do is gather the data. Luckily, sports is one of the most like widely documented fields when it comes to that. So the data was very easy to access. After doing that, I tried to train more models, but I got two main models working, which is one using AutoGluon, which we'll get into later, and the other using XGBoost. I tried to train a random forest in a neural network model, but both of those kept running out of GPU memory, like mid-training. I couldn't figure out how to get that to stop working, so I don't have those. And then after that, I built the optimization engine, which will take the outcome of the models, the predicted points, and optimize over a certain number of game weeks to select a team that will score the most points. And then I'm going to run a simulation over a season and evaluate the outcomes and see if there are any major differences between the models. So my data mainly came from the FPL API, which has complete data going back to like 2010. I only use data back to 2020 because that's when it was consistently formatted. And then I got advanced metrics like expected goals and expected assists from websites like Understat and FBref, which this provides more of like the underlying story of a player's performance in a game. So all of these were easily accessible using public APIs. They were formatted in like JSON, so I just extracted them into a Pandas data frame. And then after I had this, I did feature engineering to derive more information from the existing features. I added like rolling averages of players' form, their per 90 stats, so how well they do per game, and I added like a fixture difficulty rating for their upcoming opponents. And overall, I had around 160 features, and it was like 75,000 rows of data. So then the first model I trained was using XGBoost. Originally, I only used a regressor, but this had a big issue with players who played a small amount of time. Sometimes they would be like outliers and score a few goals, but they would never actually get selected to play again. So I implemented a two-stage architecture where there's first a classifier that classifies if the players will play a certain amount. I chose 60 minutes. And then if they are going to play that much, then the regressor will assign their points. Otherwise, they're automatically predicted 0 points. This worked quite well. And then I also used two other techniques, walk forward validation. This is just a way to simulate like a real world use where you train on all data up to a certain point to predict for the next one. So like you'll train on all data up to game week 10 to predict for game week 11. And then I also use exponential weighting, which is a way to ensure that the most recent features, most recent like rows have higher importance than data from like 4 years ago, which is obviously important in sports. So the XGBoost models perform quite well, especially in the short term. with an accuracy of around 85% for the classifier, and it was within 1 point about 73% of the time, which is quite good. However, when only looking at active players, this drops significantly, especially for the regressor. It drops down to below 45% accuracy, which this is just due to how much variance there is in the exact point scoring metric that FPL uses. It's hard to predict exactly, but what matters more is like if you can keep the ranking, which you can see in the Spearman rank correlation. It's a 0.55, which is it's pretty strong correlation, not the best. But the AUC of above 0.9 is very good, and the MAE of being off by only 1 point is also good. You can also see in the ROC curve that the predictions get worse and worse as the time horizon goes farther into the future. And in the scatter plot here, you can see that there's like a cluster of outliers at 0 predicted points. This is just due to misclassifications from the classifier, which is a downside of the model that I'm using. The other model I trained was AutoGluon. This is like a automated machine learning framework where you can like easily create pretty high accuracy models. It will like normalize your data for you, do its own feature engineering, stuff like that. And then it trains a bunch of models and chooses the best performer. Most of the time, this turned out to be light GBMXT, which is just another gradient boosting model. It differs in a few ways, but it's essentially gradient boosting. That had a little bit higher of an MAE, but compared to the average MAE for all models that it trained, it's about like 50%. That's about 50% higher. And the Spearman rank correlation is a lot higher for the AutoGluon models, which means it helps to keep the ordering better. One interesting thing is looking at this heat map, you can see how much the models improve as the season goes on. They improve by like almost 0.2 points of MAE from game week 1 to game week 38 across all horizons, which is, I think that's pretty cool that they learned throughout the season because of the walk-forward validation. And comparing the models, the XGBoost outperformed AutoGluon a little bit, but this is statistically significant due to the sample size. But AutoGluon, as I said earlier, has a higher rank correlation with the Pearson rank coefficient and a higher R² score. So it better models the relationship between predicted points and actual points. But XGBoost had a higher top 10 rate and top 10 points percentage gathered. These are just statistics I made to help measure, like it better captures the top performers. Not by much, but it is better. So then I use the output of these models. They output predicted points, and I use this in an optimization framework where the objective is to maximize the predicted points of your team over a certain horizon. I'm using 6 weeks. So both optimizations were input the same team for game week 1, and then they look at all the forecasted data. From this, they generate their optimal moves and create a new team, and then they re-optimize each game week. They also have chip usage. This is just like an extra variable that I added that's part of FPL that you use to get more points. And from here, both of the models were able to score in the top 1% of what would be the top 1% of players for the 2024-25 season, which just ended, which is very good. And AutoGluon actually outperformed XGBoost despite having lower model evaluation statistics. It scored 36 more points, which is about like a 1.5% increase, which isn't ginormous, but it's still there. This is probably due to having a better overall forecasting ability with a lower mean squared error and closer to 100% prediction accuracy. One interesting thing is that on average, about 9 out of 15 players were the same across both teams, and these were usually the high performers. So if any of you guys know soccer, like Mohamed Salah or Virgil van Dijk, just like the best players were usually in both teams. There were, I think, around 5 players who were the same for at least 3/4 of the season. And there were a few issues that I ran into. The biggest ones were chip usage. because the optimizer only looks 6 game weeks in advance, it is unable to correctly optimize for the entire season and would just use it at the first good opportunity. And the other one was bank balance. I don't know what's causing this. So this is like your budget. You can see in this graph, for some reason, at around game week 33 or so, it shoots up like really high. So at the end, they have about a fifth of their budget unspent, leading them to create a lot worse teams and have worse outcomes at the end of the season. The last one is the assistant manager chip. This is just, I didn't have time to implement it because to do this, you have to create more models that predict the outcome of each game, which would require a whole different data set. But these are all issues that are solvable and I think would vastly increase the model performance to probably the top 0.1% of players. So the main takeaways from this is that both of the models were able to accurately predict the athlete performance using FPL data. But AutoGluon was a lot easier to use, so that's probably the approach I'm going to use from now on. Just because I didn't have to mess with things, I just put the data in there and it does it. It basically does it for you. And the framework I used of forecasting and optimizing worked very well and could be easily applied to other fields where you have to make data-driven decisions or like optimize, you have like a resource allocation problem. This could happen in like finance or business or other sports, even like medical fields. And then now I'm working on converting all this into a web app where you can upload or load up your current FPL team, run the optimizer, and then it will give you suggested like moves to make over the next few weeks, along with being like kind of not a data dashboard, but just being able to compare all the different players in the database and their performances. And yeah, thank you to Dr. Alex Stokes and Kaipuni for doing the training and all the mentors, and Dr. Paruma for letting me use his Koa node.
Awesome.
Nice. How much time does it take to do one of the inference or predictions now?
So the optimizer to run it on a full season, it depends on how many of the variables you have. If you have like all the chips and stuff, it adds a lot more complexity to the problem. But it runs from start to end for 38 game weeks in around like 5 minutes or so. So it's not that long. The thing that takes a long time is training up all them because I ended up having 450 models because I have one for each. So there's 38 game weeks. I have the classifier and the regressor, and trained one model to predict for each like level of the horizon. So one would predict 1 game week in advance, another would predict 2 game weeks in advance, etc. So that was the main time constraint, but you can obviously pre-do that.
Very nice. This is
It's very cool.